So circumference. Does anyone know what? Shh, we're done. Thank you. Does anyone know what circumference is?
Thank you.
Area. Not area. Has to.
The surface.
No. It's like perimeter, but just for a circle. So instead of being the distance around, like adding all the sides up, we don't have sides for a circle. And so we're going to say it's the distance around the circle. The distance around the circle. The distance around the circle. That's what circumference is.
The distance around. All those arcs again.
Okay. And circumference, we'll call it C. We have a formula. Circumference will equal 2 times pi times r. What's r stand for? Radius. Yeah. So it's going to be 2 times pi times the radius.
What's radius squared? I know there's another formula.
That's what we'll get into later today. Yeah.
Good job, Cardi.
Okay.
You smart.
So our formula we'll use for circumference is 2 pi r. Okay. 2 pi r. So on these two circles here, we need to draw in some stuff. So I'm going to draw in like this. Now notice I ended up going through both circles there. Well, it shouldn't be a 90 degree angle, but that's okay. I'll fix it here.
That's why I have an A minus in this class.
You have a 72 in here, Randall.
I had like a 96 and I was taking a test.
I feel you.
Okay.
I have 100 in here.
No, you don't.
Now we have two circles, and these two circles have the same center. They have the same center, but are these circles the same size?
No.
No, okay, they're not. Now, what kind of angle is this 40 degrees? Paul, what kind of angle? Technically, yeah. But for a circle, it's called a central angle, because where's the vertex at?
In the
The
middle.
center. The vertex at the center, so it's a central angle.
So that
Okay.
means CD is 40.
Okay, so that means the measure of arc CD in the big circle is 40 degrees, because it's the same. What's the measure of arc AB?
20.
So if we covered up this big circle, what would it be? 40. It's still 40, right? Now, isn't that kind of weird that we have these two circles, and one's obviously way bigger than the other, but they have the same measure, right? They're still both have a measure of 40 degrees. Yes, Nick.
Is that one just because like the center circle is just smaller, so if like you expand it, it'll still go to
Yeah.
Right?
So, what? Oh, you do one of those? Okay. Okay.
Jeez. 3 of them went out at a time.
One of us got it.
Me and Randall
Our turn, let's go.
can't go out one at a time.
I never said that.
Oh. I don't know. I've never really done the math.
Alright. So, even though, so are these the same lengths from A to B and C to D? Is that the same length? No, because one's bigger than the other. It's not the same length, but it's the same measure in degrees. That's because arc length is not equal to arc measure. The length of an arc is not equal to the measure of it. Now you might be saying like, what? But you measure length. Yes, but we measure arc. Arc measure is in degrees, so it's really how much of the circle it is. Because a whole circle is how many degrees? 360. Regardless of how big or small it is, it's still going to be 360 degrees every time. And so 40 degrees is how much of the circle it is. It's 40 of those 360 degrees. But the actual length or the distance around the circle, the circumference, will change based on how big or small the circle is.
Wait,
So-
how did you know it was 40?
What?
How did you know that was 40?
I wrote that in. I wrote the stuff in the green in. Yep. You don't have it? Okay. Arc length is a fraction of the circumference. So if it's a fraction, is it the whole thing?
No.
No, it's part of it. Okay? And fraction tells us what kind of math are we doing there. Dividing, right? So a division problem. A fraction's a division problem, we're too lazy to finish. Okay? I heard that before, I really like it.
Sounds like something Mr. Titus would say.
Yeah, I got it from a teacher at Omaha North High School. It is a big school.
Yeah, they're bad at baseball.
My friend goes to Omaha Central, and there's so many people. Oh my gosh, it's huge.
Okay,
Well, then what's the record?
so arc length corollary. Okay, we have this arc length corollary here. So what that just tells us is this just this is just going to be our formula for finding arc length. So we're going to say arc length. Once again, not the measure. Arc length, like in a unit of distance, like feet, centimeters, inches. Arc length will be equal to whatever our arc measure is over 360 times 2 pi r. And we'll break it down as to why all of this is the way it is. Yep. And we can shorten these up. We can do arc length, we can call it AL equals arc measure AM over 360 times 2 pi r. So you can shorten it up like that as well if you wanted.
No.
So, arc measure. So before, on like, say the small circle, what was the arc measure on that? 40 degrees, okay? So if your arc measure AM was 40, so 40 degrees out of the 360 degrees. What is, you don't have to write this for your question. What does the 360 degrees represent?
The whole circle.
The whole circle. 40 is just the part we're looking at, right? It's just this little section that we're looking at here.
But it could be the big section too.
It could be, you mean, this one?
Yeah.
Okay, if we were talking about the big circle, yeah, it could be that. So right now, if we're just talking about the little circle, it's just this little section of that circle. And so we can say, okay, this 40 out of 360, that's saying how much of the circle are we looking at? So what we can do is we can reduce this fraction and make it, oh, we're looking at this much of the circle. So how would we reduce this fraction? What would be a good first step in reducing this? Okay, divide by, okay, common denominator, common factor. Okay, I heard 2. What about these zeros? Can we divide by 10 right away and get rid of the zeros? So we could have 4 over 36. You cross them out, but that's because you divide by 10. Okay, so now we have 4 over 36. What goes into both 4 and 36? 4 does. I heard 2. We could do that and get there. But 4 goes a little faster. So how many times does 4 go to 4? How many times do we go to 36? 9. So we're saying we're looking at 1/9 of the circle. That's what we're saying we're looking at, 1/9 of it. So if we're looking just at 1/9 of the circle here, how much would the rest of the circle be then? 8/9, right? If this is 1/9, this would be the remaining 8/9, wouldn't it? Okay, because together they have to make a full 9/9. 9/9. Okay. So if this is 1/9, this has to be the remaining 8/9 there. Okay, just kind of talking about that so you can kind of understand. We're just saying how much of the circle are we talking about? How much of the pizza? How many slices of that are we talking about? How much of the pie are we talking about? That kind of stuff, okay? How much of the circle are we talking about? We're talking about 1/9 of it. So this part right here in our equation is just talking about how much of the circle. So how much of the circle? That's what it's really asking. It's really just asking how much of the circle are we talking about? Oh, we're talking about the 9th of it in this case. And now if we were doing this big circle, how much of the circle would we be talking about there? It's still 1/9, right? Because it still is 40 degrees. And so you still would take the 40, you would still take this 40 divided by 360, and we're still talking about 1/9 of the circle, regardless whether it's the big circle or little circle, we're still talking about 1/9 of that circle. What's this 2 pi r represent? It's circumference. Did we just say circumference is equal to 2 pi r? Let me see it again here. So this is talking about our circumference. And you can just put C there if you wanted. That's talking about our circumference. And circumference we said is what? the distance around the whole circle, right? So we're saying we don't want the whole distance around the circle just for this little length here. If we're just finding this length here in the dark blue, we don't want the whole circle, but we need to take the whole circle's length, just around the whole circle, and then say, okay, well, we only want a ninth of that, and now we get what we have. So you multiply 1/9 times the whole thing, and you get how much you want. Does that concept make sense? How we get there? Okay, you say if we want a ninth of it, take the whole thing and say, I just want a ninth now. So you multiply by 1/9. It's like you're saying if you had money, for example, and you're splitting money 4 ways. Okay, so let's say you're splitting, I don't know, $200 4 ways. What would you do to get figure out how much your share is? Divide by 4. Now, is that the same thing as multiplying by 1/4? Yeah, it is, because this is like 200/1, and so you multiply straight across, and it ends up being 200/4. It's the same thing. So here, when we take 1/9 times the whole thing, we're still really just dividing by 9, essentially. Thank you. We're on to our new notes right now. Thank you. Okay. Any question on this kind of this idea, this concept of that? So I think if we understand the concept, the actual formula will become a little easier to us to use. It will become a little easier to us if we can understand the concept. Okay. So if we go around the little list, let's practice it. Okay. Now here, we have another circle. Once again, it's not marked. I just didn't get around to being able to mark it in time. So no. But it's not the end of the world.
So it's not a center.
So everything, this is on the center.
Okay.
Yeah, that is the center. Thank you. Okay. So it's kind of a rough sketch what I have. It doesn't have to be perfect. You guys know mine's not. Drawings are never perfect. You guys know that by now. If you've learned anything in this class, it's probably that, right?
And your handwriting has improved. And
My handwriting has improved. Thank you.
Yes.
And mine is parked over too. You,
That's the only thing I've retained.
you know I get jacked over that. There's all sorts of hypes. What?
I'm just really tired. No. Where you been? Oh, in the bathroom. Sorry.
Alright.
Oh yeah, the bathroom.
So this part, the red, is what you need to add on to your notes right now on that section. Does everyone have that in there?
Wait, is it just because simply we didn't have it? Or
Correct. Yep, simply because you didn't have it. I had to write it on mine too. Okay? So if we're, what are we asked to find on this one?
Measure the AB.
The length of AB, not the measure, the length of AB. Now we're asked to find the length. Now we said arc length is equal to arc measure over 360 times 2 pi r. Now let's think through this. If we need length, we need to find this part. Okay, we have 9. What's 9 mean? That's our, what's 9 represent? The radius. I didn't hear, sorry. The radius, it's the radius. Okay, so 9 represents our radius. So are there any other variables we need to know over here in order to find arc length? Your measure, we need our arc measure. Can we find our arc measure right now? What is it? 45 degrees, because this is the central angle, isn't it? Okay, so the red is what we were given, the green is what we're working from now. So you can find arc length. What do you want to call this arc length? You don't know what it is, could we call it x?
Yeah.
Okay, is that simple? Okay. X equals what over 360? 45 over 360 times 2 times pi times 9. 9. That's how we set up our formula. Questions on the setup before we do any solving? Okay. You were saying something?
Don't we need 3.1?
Yes.
Yeah.
And stand for arc measure. What was that?
Are we going through all this here?
Once
It
again,
doesn't matter if
in the back.
they're capitalized or not.
The AL and AM.
Don't need 3.14.
Right? What are you saying 3.14, Nathan?
Pi sign.
Okay, pi. Pi never ends. It just doesn't end. It just goes on forever. So oftentimes it's approximated just to be It's just approximated to be 3.14. We'll talk about that here in a second. But for now, we'll leave it in terms of pi. Okay, we'll leave it in terms of pi as medium. We'll just kind of leave pi in there. Okay. You good, Randall?
Stretch.
That's a stretch, all right.
So if we take 45 divided by 360, let's make that a fraction. Let's make that a smaller fraction here. Okay, so we can reduce this fraction. Randall, let's go back to receipt, please. 45 divided by 360. We say, okay, what goes into both of those so we can reduce this? 5, okay? So we can start with the 5. How many times does 5 go into 45?
9.
9? How many times does it go into 360?
Oh,
We don't know, how can we figure it out? Calculator. Take 360 divided by 5. Okay, you said what? 40? No? 72? That sounds right. Okay, so we can say x equals 9 over 72 times, what's 2 times 9? 18 pi. Does 9 over 72 reduce anymore?
Yeah.
It reduces to 1 over 8. They can both simplify by 9.
Wait, where's the 2 go?
The 2 in front of the pi,
Yeah.
we took 2 times 9.
Oh.
Because we can multiply in any order, can't we?
Wait, so what do we do with the 9? I'm so confused.
So we multiplied this 9 or this 9?
The top first 9.
This one?
Yeah.
Okay, so we reduced 45 over 360. We said, oh, 5 goes into it 9 times and 72 times. And we said, oh, but 9 goes into both of those once and no times. This is an 18 pi. Let me rewrite that.
You're good, Mr. Gossel. You're still getting there.
Okay, thanks.
How'd you get it?
Maybe one day.
How did I get what? Which part? 18 pi?
Yeah.
Okay,
You just-
so we had 2 pi times 9. And we can multiply in any order. So what's 9 times 2? 18. So we have 18 times pi. And we'll just leave it as pi right now, okay? Any other questions on how we got here so far? Okay. So 1 over 8, that's how much of the circle we're talking about. We're talking about 1/8 of the circle. And we're saying the whole circumference of the circle will be 18 pi. So if we multiply these together, that's going to figure out our length of just A to B. So what we do is we say, okay, how do we multiply fractions? You put it over 1 and then you go diagonally? No, not multiplying. You do what?
Go left to right.
Yeah, straight across, left to right. So 1 times 18, so 18 pi over 8. Okay, can we reduce that anymore? What goes into both 18 and 8? 2. So we get 9 pi over 4. Can we reduce that anymore? No, okay. So do you guys remember finding approximate and exact answers before?
So now we need 3.14
Okay.
times.
Do you guys remember finding exact and approximate answers before?
Yes.
Yeah. What was the difference between the two? Good, Nick.
Actually, I got a question.
Okay.
Why didn't we multiply pi?
Because that's what we're talking about right now. Okay. What's the difference between exact and approximate?
Exact. It's exact.
Okay.
It's a number.
Mhm.
And approximate is a round number.
Very good. Approximate's a rounded number. Now I said pi never ends, right? So 3.14 is an approximation. It got rounded to it, okay? You just go ahead and set them off now. So it's an approximation. So that means if we ever multiply this, we're gonna have to round. So right now, this is an exact answer. 9 pi over 4 inches. That's the unit we're using.
Oh, okay.
Okay, 9 pi over 4 inches. That'd be the exact answer. So x is, we get to find the approximate answer by taking 9 times pi. Now, if you have one of my calculators, it says there's a pi button on there. Okay, so if you have one of those TI-30X, it has a pi button on there. You need help finding that? I can show you it.
We have to do
Put a pi through.
If it asks for a decimal, then you have to do it. If it asks in terms of pi, this would be your answer.
Where is it?
Okay.
What do you do?
You don't see it either.
Oh, no, I thought I had the same one.
Okay, so you just do three. Oh, there it is. Right there. So it's right next to sine, cosine, and tan. It's right to the left of sines. Okay, so if you have one of my calculators, it's right to the left of sine. So you just type in 9. You can just type in 9 pi divided by 4.
Is it 7?
Point seven.
I have 7.0685.
Okay, so let's call it 7.07, rounded to 2 decimal places. So it's approximately 7.07 inches. So it's exactly 9 pi over 4 inches, and it's approximately 7.07 inches. There's advantages to both using approximate and exact. Approximate, is this a number that we're more familiar with? If we say it's about 7.07, are we more likely to know about how long it is? Yeah, but the thing is if you're going to do more math with it, it's nicer to leave it as the exact because you didn't mess with the number at all. Because when you round, you get a little bit off as you keep going. So if you're going to do more stuff with it, it can be handy to leave it as is. Okay? Get Lily.
Are you going to want both approximate and exact?
I'll ask for whatever I'm wanting. So if it says in terms of pi, that means we leave pi there. If it asks for a certain in decimal, then we want this. Okay, Randall.
Now, how do we get the other way?
Go back.
Yeah, like we're like got a problem and get the approximate. How are we supposed to find the circle?
Like how are we supposed to find the exact, or how are we supposed to find like the radius, or
All of it. Like if you're just given the circle, and the approximate, how do you go back?
we'll talk about some of that in a bit. Good question. I'll kind of table for now. Well, 7.07. Okay. One thing I do want to talk about as well, though, is this 9 pi over 4. Heads up, this can be written slightly differently as well. It's still the same thing. You can write it as 9 over 4 pi, like this, and that's the same thing.
Don't forget,
Because at the, inches. And because at the end of the day, if this is pi out here, what's operations happening between these two? Multiplying. It's still being multiplied, just like this 1 over 8 times 18 pi. It's still multiplying. Okay. And so if you were to multiply it together again, this would be like pi over what? 1. And would you still just get 9 pi over 4 again? Yeah. So you can write it either way, okay? So if you write it as 9 over 4 and then the pi off to the side, it's the same thing as writing it 9 pi over 4. Same exact thing. Okay. Just a heads up, so I might write it this way sometimes, you might see it that way, you might see it this way. Heads up, so it's the same. Okay. Let's see if we can try this process on example 2 here, okay? So on example 2, this pink is what we have to draw in.
I made it go the wrong way.
Okay, so where you draw in those points,
Is that 5 or 15?
15.
what's the
Just J chill and ready to be used.
That worked.
Yeah, it's super spotch. Save all me. Okay, does everyone have this pink? This pink that just got added in. Okay. So we're supposed to find the length of what arc? CED. Is that the big one or the small one? The big one, okay?
You can do this without doing all that work. Yeah.
How?
It's a semicircle. No, it's not. Okay, so you see like the 90 degrees thing? If that angle is 90 degrees, then it's the center thing.
Central angle.
Approximate's 90, so the rest of it's, I don't know the math, but it's 360 minus 90.
Okay, so we know this whole arc here, the arc measure is 270 degrees. Okay, Do we need arc measure to find arc length?
Yes.
Yeah. That's good, we found it. What is? The arc measure. Because if this is 90 degrees here, the rest of this must be 270. So the arc measure for arc CED, major arc CED,
Wait, what's the difference between the arc measure and the arc length?
okay, measures in degrees and it's how much the circle is. Length is the actual distance. Okay. It's from the very first part we were kind of talking about. So now we fill in our formula again. So we say AL, what do we want to call AL this time? Cool. Is equal to our arc measure, which is what? Divided by 360 times what? 2 pi times 15, whatever our R is. So that's our setup there. Okay.
Multiply 270 and 360 by 10.
Okay, so Kylie's saying, hey, let's reduce this fraction. 270 and 360, we can reduce those both by 10, getting rid of those zeros. So 27 over 36, a little easier to manage. Okay, what goes into both of those?
3,
3 does. Okay, is there anything bigger that goes into both of those?
9,
9 while we're at it. Okay, how many times does 9 go into 27?
3,
How many times does it go into 36?
4.
4. And how many pi would this be? Okay, so we say how many times does 9 go into 27? 3 times. Right, it goes into 36 more times, so we reduced it.
35.
And 2 times 15 is 30 pi, because we can multiply in any order here. Okay? Do you guys want to learn a trick on your calculator to reduce these fractions? Okay. So if you have one of my calculators, one of these TI-30s, you can do it. One of these scientific calculators, you can do it on there. So raise your hand if you need one. I might not have enough for everyone, but I'll try and get around or have you share with people after you learn it. Okay. Lily, I will let you borrow from me as soon as we go through it once. Okay. So what you do is you would type in your division problem. You type in your fraction, which is division problem. Okay, so you type in 270 over 360. Type that in, push enter. 270 divided by 360. Type in that fraction, you push enter. Okay? And you should get 0.75, right? 0.75. Now, we might know already, oh, that's 3/4. We might not. Okay, we might have other numbers. Like you can do this on the 45 over 360 from the last problem as well. Okay? Then what you do is while you still have that in your calculator, you still have that 0.75 in your calculator. If you look right next to that second button, diagonal from that second button, you see a button that says PRB. Okay, if everyone's looking at that PRB button, above it you see an F with an arrow and a D, right? Fraction to decimal, or vice versa, because the arrow goes both directions, right? That button's saying fraction to decimal or back. So whatever you're in, you push second to get to that button, then you push that fraction to decimal button, and you push enter. And what happened? It gave you the fraction. And if you push it again, it gives you the decimal, because it goes back and forth forever. Okay? If you understood that, and you're, can somebody give their calculator to Lily, and somebody give their calculator to Kylie, so they can see it as well? There you go. Thank you. Okay? So you type in a fraction. So you can type in 270 over 360, or 45 over 360 to see it now. Yep, you do the fraction we have there. And then you push enter. And you get 0.75, right? Then you push the second button. And if you look diagonal from the second button, you see that PRB button? You can see above it how it says F to D, fraction to decimal, or vice versa, because the arrow's going both directions. Push that button. And it should say answer. You push an extra button after that. I'll just delete it out. Okay. And so it says answer, and then fraction to decimal button. Okay. So then you push enter, and it gives you the fraction. And if you do it again, you go second to that button and give you the decimal. Do it again, give you the fraction. Do it again, give you the decimal. So,
Any decimal, can you press the second and the PRB?
if it has a fraction, you'll find it, yeah. Questions on finding those? Have a little handy trick on your calculator. Whenever you guys go take the ACT as well or any standardized test, and you're trying to remember, hey, Mr. Coswell, how do I do that fraction to decimal thing? Because it's handy for the ACT. You come in and ask, I'll show you how to. Okay. So continuing on, we need to take this 30 pi times 3 over 4. So it's like 30 over 1. So how much pi really is this? How many pi?
90.
90, thank you. 90 pi over 4. Or 90 over 4 with pi outside, either way is okay. And can we reduce this anymore now?
45.
Okay, 45 and 2 divide by 2, and we get 45 over 2. Can we reduce that anymore? No, we cannot. So it's 45 over 2 pi inches. That's our arc length. And we could figure out the approximate as well. So this would be our exact. And to figure out our approximate, do we really have to do that much? Okay. Type in 45 pi over 2.
So it's over 2.
Divide by. Because over just means division. Okay. Don't blurt, don't blurt, don't blurt. Let's round to 2 decimal places. 2 decimal places. Okay, and raise your hand if you got it for me. Okay, Nick. Okay, 70.6, that is 3, 6, 6, 9. Okay, 70.69 inches. Okay. If you got a different, Nick, did you do 3.14 or pi?
I just multiply 90 by 3.14, then divide by 2.
So if you do 3.14 instead of pi, you get a little bit different. Nick got 70.62. Is that much different than this? No, just slightly, okay? So if you go through and you do 3.14, I'm not going to count it wrong. Okay, I'll do the math as well, make sure, oh, he might have done 3.14, she might have done 3.14. Okay, you're good.
Just type in 270 over 360 times 30 pi.
You do, yeah. So if you type this in earlier, okay, Carly made an observation. Hey, Mr. Carlos, can we just type this stuff in earlier? You get the same thing. We have to do this work. If you need it in terms of pi, you do. Okay, and was reducing that the worst math we've done? No, it's math we've done before.
Is this tested?
Okay, quiz.
Oh,
it's
we're
the
taking a test.
No,
It's on the board.
It is
I
on the
was
board.
gone when you were like this.
Okay. Any other questions over this example? So most of Wednesday and most of Friday will be a review program. Okay,
It's on the
when's
board.
it say? You're not really the person.
Friday?
No, what does it say on this board?
There's a glare.
Okay, it's on next Wednesday.
I didn't even see there was.
Okay, questions on example 1 or example 2? Okay, here's what we're gonna do for example 3.
Sweet.
Okay, let's look at example 4. Go ahead and get out your notes. Okay, go ahead and do it.
I didn't know I put redrawing.
We could, okay? So if you look at example 4, the diameter of a bicycle is 30 inches. Diameter of a bicycle tire is 30 inches, okay? So you have this bicycle tire, we're told that the diameter is 30 inches. Do we need the diameter? What do we need? Radius. How do we find the radius? Divide by 2, so the radius is 15 inches, okay? We're asked to the nearest foot, how far does a tire travel when it makes 100 revolutions? So we need 100 revolutions. Well, first of all, let's think before that. What would be 1 revolution?
One time it goes all
One time it goes all the way around, right? So would that be its circumference? If it's 1 revolution, would that be 1 distance around the whole circle?
Yeah.
So we need its circumference. So we need to find what the circumference is. And if we find the circumference, what can we then do to it to make sure we found 100 revolutions? Multiply 100. So if we think conceptually, what do we need to do? We analyze this and say, okay, we need 100 revolutions. Let's first see if we can find 1 and then multiply to get there. If we find 1 revolution, will it change? Will each revolution be the same or different? The same, right? The tire's still the same length, same circumference every time. So we said circumference is equal to 2 times pi times r. So if we have circumference is equal to 2 times pi times 15, what's circumference equal? If we have circumference is equal to 2 times pi times 15, it would be 30 pi. Okay, and 30 pi inches. And we said we need how many of those? 100 of them. So we take this 30 pi, we multiply it times 100 revolutions. And what do we end up getting? A 3 with how many zeros behind it? 3. You take how many zeros and you add that many zeros for the add as many zeros as are in the 100. So we end up getting 3,000 pi inches. Questions on this so far? How we got here?
Is that an extra multiplication?
Multiplication.
Okay.
Yeah,
I
good
have
question.
this packet.
You were asked for that.
I need all that.
Okay.
Hey, my energy beats the football.
Where's the stapler at?
It's actually beautiful.
I'm really
Are you
tired.
Okay.
Alright. So you take 30 pi, the 1 revolution, the 1 circumference, multiply by 100 of them, because that's what we need. And we were asked to find it to what? To the nearest foot. So do we have to multiply this till 3,000 times pi? Yeah, we do. Okay? And what would that end up getting? Approximately what?
94.7.
Okay? Okay? Approximately 9,424.78 inches. Continue on. And that's in inches, right? Okay? How many inches are there in a foot? 12. So if we had 12 inches, how many feet is that? 1 foot. How would you get there? What operation would you do? You divide by 12. So whenever you're going inches to feet, you divide by 12. So to go from inches to feet here, we would divide by 12. If you ever get stuck saying, I don't know how to get from inches to feet, do I divide or multiply? Think back. 12 inches to 1 foot, oh, you divide by 12. Okay? And this would give us our amount in feet. It's approximately what? To the nearest foot. So to the nearest foot, it'd be 785 feet. Okay? We gotta be really careful. You're given inches to start as to end in feet. So if a tire makes 100 revolutions, you went approximately 785 feet on your bike. Questions on that? Okay. Let's think about it this way too, as far as the multiplication or division by 12. If you had to multiply by 12, would we have a much bigger number? Should we have more inches or more feet? More inches, right? So feet should be smaller. So if this number got bigger, that's an issue, okay? That'd be a lot of feet, okay? That'd be like 81.
All that to go almost 3 football fields.
Yes. Yeah, it'd be like over 10,000 feet. Over 100,000 feet. It'd be a lot. Okay. Wouldn't want that. Questions on 4?
No.
Okay, let's continue on. Go to the next page. We're almost there, guys. We're gonna get this bread.
I just said we were.
Obtain the grain. Eat the wheat.
What was that answer?
Trust the crust. What was that, Kennedy?
What was that answer?
Approximately 785 feet.
Are you doing both of the examples?
I tracked one.
What was that?
I know you're doing example 5 and 6.
We're gonna try 2. We'll see how we get. Okay. So earlier I said someone asked me about r squared. Was that you, Carly?
Yeah.
Okay. So when we find area of a circle, we said area is the space enclosed by the figure. So it's all the space inside a circle. Area of a circle will be equal to pi r squared. So you still use pi, you still use a radius, and you still use a 2. Well, here's how we can keep this straight, though. Okay? So for circumference, we did 2 times pi times r, whereas for area, we end up squaring r. Well, when you have circumference, you end up having whatever units you had, and it was just that. It was just that in units. You end up saying like units. For area, you deal with square units. Square inches, square feet, square centimeters, square miles. You deal with square units. Okay? You don't have to write that down if you don't want to. It might be a good idea to use the units with a square behind it. We write it units squared, but we always say square units. It's like, my apartment is so many square feet. That's how they calculate the area. So they can figure out how much they can charge me and whatnot. Okay? A house is so many square feet. Property is so many square feet. Miles, acres, depending on your unit of measurement. Okay? So for area, we end up saying it's a square unit. So we end up squaring in the formula. Okay? Now, sector of a circle. If we didn't want the whole thing, we want a section of it. The section kind of look like sector. Okay, so think about that. Section, sector. A sector of the circle is the region bounded by two radii of the circle and their intercepted arc. And I'm sorry about the spacing on this line. I know it's kind of weird and janky. I'm going to draw a picture so we have a better idea of what we're talking about here. So there, if I have my perfect circle, not even close to an oval, right? Just a perfect circle there.
Hey, that ain't too shabby for an old.
Honestly, it's one of my better ones.
It is. You're getting there, Mr. Thompson.
Hey, thanks, you know.
You did.
Couldn't get worse, right?
You can only go down.
Okay, okay. So if we're talking a sector of the circle, we're saying it's a region, it's an area, bounded by, it's like, think like sports out of bounds. It's bounded by, those are the edges, two radii. Is this a radius?
Yeah.
Is this a radius?
Yeah.
Are these two radii? Yep, that's one of the boundaries, and their intercepted arc. So it's bounded by all of this, and this area. So we're just talking about this slice of the pizza. Okay, this slice of the pie. And in this case, we're talking about all of this area inside the sector. We're talking about all of the area inside the sector there. Whereas for arc length, we were just talking about the distance around the circle for that little part. It's this little part up here. Okay. For sector of a circle, we're talking about the area of the whole sector here. We have an equation for sector as well, for area of a sector. Okay? And I think once I explain it, you guys will be like, oh, okay. So area of the sector is equal to your arc measurement over 360. Does that look familiar at all? Arc measure over 360. Did we just use that a lot? Okay. Times, instead of 2 pi r, times pi r squared. Now we said the arc measure over 360 was what? It's, what did we write above it on the first page? How much of the circle it is. We're still talking about the same thing. We're still asking, how much of the circle are we dealing with? We still want to know the measure. So if this is 40 degrees, we still want to know, oh, we're dealing with 1/9 of the circle here. We're still trying to figure that out. Now instead of the circumference here, what do we have here? The area. So instead of circumference, we're talking about the area. So when we found arc length, we said, oh, what's the whole length around the circle, the circumference? We just want part of it. Here we're talking about area of the sector. We're saying, okay, what's the whole area? Oh, we just want a part of that. So the first part of the equation stays the same. You still just want a part of the circle. We're talking about how much are we dealing with. This part is what changes. We're just talking about the area instead of circumference. Only part that changes. So if you're dealing with area, you put area. If you're dealing with length, you put the circumference, which is distance. Does that concept make sense of why this is different, but also very, very similar? And very similar in how it's come up with, but different because of the area. Okay, let's look through example 5 and try setting this one up, okay? So this one's drawn in for us. We don't have to do any additional drawing right now. It says, find the areas of the sectors formed by angle HJK. So here, if you look at this angle HJK, you kind of see two sections here we can have, okay? Let me highlight them here. So we can have this being this could be one sector there, in the yellow. Does anyone know what our other sector would be? The rest of the circle. Because technically this really just formed two sectors by doing this, didn't it? Okay? Alright, so Nathan explained that. You're saying, would this be 260 right here for this arc measure? Why? Okay, so this is the central angle. We know this is going to be 100 degrees. That's 100 degrees. This one has to be the remaining 260 degrees for the measurement. Okay? Very astute. Okay, so if we were just finding the yellow sector first, the yellow sector, is that the bigger or smaller sector? Smaller, okay? Remember when we had big arcs and little arcs, we called them minor and major arcs? Okay, this will be a minor sector. Okay, the blue one would be what kind of sector then? A major sector. Okay, tell you what. Okay, so for this minor sector, we say the area A is equal to what over what? 100 over 360, the arc measure divided by the measure of the whole circle 360. How much is the circle? Times what? Pi r squared. What is r in this case? 12 squared. Our radius, whatever, is over here, which is 12 squared. Okay? So 100 over, well, first of all, excuse me, before I continue on, question how we got that. Okay. What is 100 over 360? We can simplify this to find our exact. Okay? 5/19ths? 5/18ths. That sounds better to me.
Yeah, I did that calculus.
5/18ths, you did that calculator trick. Let's go, okay? 5/18ths times, and I heard 12 squared was 144 pi. Okay, we reduce that to 5 over 18ths times 144 pi. Okay, now we can take 144 times 5 and we get 5, 144, 720 over 18 pi. Remember that pi can either be on top or out to the side. Either way is okay.
41.
Okay, and it reduces to what?
41.
40 over 1, which is really just what? 40. So it ends up just being 40 pi square centimeters. It ends up being 40 pi square centimeters. So that one worked out pretty nicely, didn't it? We didn't even have a fraction at the end. We like that. Sorry about that. Okay. So this is the exact, could we find the approximate?
Yes,
How would we do that?
40 pi.
Just take 40 times pi, right? Okay, I'm not going to make us do that right now. And this would be which one, the major or minor sector?
Minor.
The minor sector, okay? Now the major one, should the major one be more or less? Should it be more or less? More, right? Okay. So how would we set up our major sector? Can somebody help me set up that one?
The same way as the minor.
The same one, so we do 100 over 360?
No, like
No.
260.
Oh.
I said the same as.
Oh, okay.
Yeah.
So we do 260 over 360.
Yeah,
Why is it 260 this time?
because it's another.
Because that's its measure.
It's the area.
Is this pi still pi 12 squared? Yeah, because did the radius change?
Oh.
No, the radius doesn't change for a circle. So now, let's do some thinking real quick. Before we even try and reduce 260 over 360, if this was 5/18ths, how much does this have to be?
6, 7, 8.
13. How'd you get 13? Take 18 minus 5, and you get 13. Because they have to add up to being a whole, so that would be 18/18ths together. And you can do that in your calculator or reduce it like we did before, and you get that. Thank you, Ms. Hessel. And this would still be 144 pi.
1872. 1872.
Okay, Nathan's jumping the gun here and saying, hey, 13 times 144 is 1,872 over 18 pi. And that ends up being what?
104
Is that 1812?
1872. It ends up being 104 pi square centimeters. Exactly. Yep. Now could we find the approximate? How do we do it? Multiply 104 times pi. And which section did we find here? Major or minor? Major. Now should it be fairly obvious which one of these two is major? Why? It's a much bigger number. Okay? 104 pi is bigger than 40 pi. Okay? We are done. I just want to say one more comment. We're not going to do the last example. I want to do one more comment. This might help you on your homework. Okay?
Wait, I don't know how to do about one.
It's the same thing as what we did in the previous one. Okay? So, one thing I wanted to say is, if you had, like, earlier equation, circumference is equal to 2 pi r, let's say we were given the circumference. Okay, let's say we were given the circumference was, I'm just going to come up with something random, 10 is equal to 2 pi r. And we were asked to find radius. How would we go about this? You divide by 2, okay? And then you have 5 is equal to pi times r. Divide by pi. And you have r is equal to 5 over pi. And if you were asked to leave it in terms of pi, would you be done? Yes. If you're asked to leave it in a decimal, would you be done? No, you divide that. Now, could we have divided by 2 pi at the same time? Yes. Okay? So this is just solving for a variable in the equation there. Okay? It's not new math to us. It's math we've done before. There's going to be homework like that, yes. Okay? Yes. Okay. If you missed the first part of the lesson, please go back and watch that video. I'll have it posted later. So that way you guys are able to know what to do.
Do you put me on the study hours? Nope. It's not.
I haven't yet.
Okay, well, I have a volleyball meeting at 3.
You got big crappy then.
Randall, so what do you think of it?
She likes it.
But
But you still like it.
Hey class, reminder, we have one more section we'll learn on Friday and Monday, and then on Wednesday we're quizzing and reviewing, and on Friday we're reviewing for our final.
Oh my gosh, finals are 2 weeks.
Yes.
Oh god.